So hello everyone and welcome to today's webinar on our BGP and RPKI topic. I am Apurva Todkar and you are joining us here as a part of the DE-CIX Academy. So let's dive right into it by starting with RPKI. First, we'll discuss its motivation and why deploying RPKI is crucial. But before that, let's clarify something. So what exactly is RPKI? And acronyms like this can be pretty confusing, so it's important to spell them out correctly. So RPKI here stands for Resource Public Key Infrastructure. So now let's break down further and understand its purpose and the functionality and how it can enhance the security of your routing infrastructure. So RPKI is about digitally signed object, specifically the digitally signed route and resource objects. So let's first understand what routing resources are. So routing resources refer to the IP prefixes that you receive from your regional internet registries, that is your RIR. And for instance, in this example of the prefix 192.0.2.0/24 is a resource you might have obtained from your regional internet registry. So for instance, in the example, as I said, 192.0.2.0/24 is a resource you might have obtained from RIPE NCC or ARIN or APNIC, depending upon your region. So in India, if you consider India specific, APNIC is the one who takes care of this. And the key question here is, how do you prove that this prefix belongs to you? How do you prevent others from claiming or misusing it? So this is where the RPKI steps in. So RPKI allows you to cryptographically sign your routing resources with the help of your RIR. So you receive a certificate from your RIR stating that yes, this prefix belongs to you. And with this certificate, you can define how your prefix should be announced over the global internet via BGP. You can specify autonomous system numbers uh, with a particular prefix such as AS19961. So you can set restrictions on how your prefix can be announced. So for example, if your prefix is a /16, you can specify that it should only be announced as a /16 and not broken into smaller prefixes like /24. So this is done basically by creating a ROA, that is nothing but a route origin authorization. So ROA is a digitally signed object where you and as a resource holder can define how your prefixes can be announced. So using this ROAs, routers can then validate this BGP announcements and ensure that only authorized announcements are accepted. So improving the overall security and the integrity of the routing system. So what problem are we trying to solve with RPKI? So traditionally, routing resources such as IP prefixes and AS numbers have relied on databases like WHOIS for verification. However, the accuracy of the WHOIS data has been questionable, but many entries being outdated or incorrect in the WHOIS database. So RPKI aims to address the issue by introducing certificate-based proof of resource assignment. So using RPKI, resources like IP prefixes and AS numbers can be verified through cryptographically secure digital signatures. So with RPKI, resource ownership is provable. Like you receive a certificate from your RIR stating that the particular prefix and AS number belongs to you. You can then authorize any specific AS numbers to originate your prefixes, ensuring that there are no unauthorized announcements from other ASNs for your prefixes. So this cryptographic verification eliminates the any ambiguity or any uh, security threats that are generally pertaining the reliability of the internet routing. To summarize, there are only 5 entities worldwide responsible for the assigning of the IP resources, like the IP addresses and the autonomous system numbers. And these are called the regional internet registries that are your RIRs. So we have 5 RIRs, the first being the RIPE NCC for the Europe and the Middle East and some parts of Central Asia. Then we have the ARIN for the North America. Then we have APNIC for the Asia Pacific region, which includes India as well. Then we have LACNIC, that is the Latin America and the Caribbean, and we have the AFRINIC for Africa. So these RIRs act as trust anchors in the RPKI model. So each RIR publishes a root certificate, a public part of their certificates, and maintains a contract with every entity to which they allocate their resources. So when a RIR assigns a particular IP prefix or an AS number, they issue a cryptographically signed certificate confirming that the resource allocation, like for example, if RIPE NCC assigns a prefix, I'll just show you. So in this case, when a RIPE NCC assigns a prefix, like for the in the example 91.214.253.0/24 to an entity like us, like DE-CIX Academy, so they sign a certificate verifying that this resource belongs to them. So this system ensures that resource ownership is securely verifiable through RPKS trust anchors and simplify the validation process. So what can you do with this certificate then? So ROA is nothing but a route origin authorization. It's also a digitally signed object that specifies three critical values. The first one being the IP prefix, the specific block of addresses that is being authorized, and the second one being the autonomous system number, and the AS allowed to originate that particular prefix, and the third option being the allowed prefix length that defines the range of the subnet marks, like for example, from a /24 to a /32 that can be announced for the prefix. And the ROA is signed using the resource holder's RPKI certificate, and its validity is verified through a chain trust extending to the root certificate of the respective RRs. In the example I took was the RIPE NCC one. This is a prefix, the 91.214.253.0/24, and the originating AS that I allow is AS196610 to announce the prefix. And the allowed prefix range here is up to /25. So what your ROA file, the ROA file will contain these three values, the prefix that is the 91.214, then the originating AS and the allowed prefix length from the /24 to /25. And when the actual ROA is generated, it includes additional details as well, like the validity period. Like you can see in this ROA, the specifically there's an validity until 1st of July that is mentioned over here. 1st of July. Okay. And after this period, the ROA must be renewed or reassigned, maintaining its validity so that you ensure that precise route management is being taken place. Part 2 of RPK setting it up. So now that you have your certificates and the ROAs generated, the next step is setting up it in practice. So the simplest approach here is to use the hosted RPK services. So you may ask, what is hosted RPK? In a hosted RPK setup, your RIR, for example, the RIPE NCC in Europe, they manage the certificate and ROAs on your behalf. And in our case, it is managed by the APNIC. So they handle the key management, the signing, and the regular key rollovers that are being taken place. So, for example, as I shown you earlier, if your key needed for a rollover over a month ago, the hosted RPK setups would ensure that this process happens automatically or seamlessly. So why would you choose a hosted RPK setup? First benefit being the ease of use, because most of the RIS provides a user-friendly web interface to manage their RPK related tasks. So you can have an AppNic account or a RIPE NCC account wherein they have a GUI setup wherein you can publish your ROAs over there and assign which ASN number should be associated with the particular prefix. So that's a pretty user-friendly way to actually host those RPK entries. Okay, so there's a minimal overhead also, so you don't have to worry maintaining about your own trust infrastructure into it, because all that is being taken care by the RIRs only. And the second being the running the setup on your own, like who runs their own RPK, if you would ask. Only very large organizations with a very complex, typically manage their own RPK infrastructure. So if you are learning about RPK this first time, so hosted RPK is actually the way to go, and everyone generally prefers this method only. But in our case, if you consider India, many of the people don't have their AppNic account and they rely on IRIN for the resource allocation. So in that case, you tell IRIN that these are your resources and these are the ROAs that you want to generate for your prefixes, and what is the source originating ASS for it, AS for it. So they bind it for you, and the particular ROA is being created so that it happens without us intervening anything for that tweaking methods. Like I said, that hosted RPK makes managing your prefixes easier by letting your RIR handle those certificates and updating the keys and publishes the ROA and managing all the trust chains that they have. And I gave an example of RIPE NCC who has a simple web interface, and many other IRS also have their different tools. You have to check with your provider what tool they provide to you. And also creating a ROA is also very easy. You confirm which prefix and the AS numbers you want to allow to announce with it. However, if you move a prefix from one ASN to another ASN, you don't forget that you have to update your ROA as well. So if you don't, then your BGP announcements might get rejected, causing issues with your routing as well. So remember that if you're jumping from one AS to another, so do remember to update your ROAs also. Otherwise, many of the transit providers and the peering partners don't allow such announcement if you had an invalid ROA created with it. Next step is validating your ROAs, so that now you have the ROAs and the prefixes. The next step is for the routers to validate these ROAs. Okay. So this is done using a software called as a validator, which runs on a server and not on your router. Okay. Because router itself has to handle the routing task. This validator part is not being taken care by a router any which ways. The first step being is the fetching of the ROAs and the certificate. So what the validator knows is where these 5 trust anchors are located, and they have published these certificates and the ROAs. So it fetches this using protocols like rsync. So rsync is a very popular protocol wherein this validator is used to actually fetch those certificates and have a proper database maintained. The second step being is the validation process, wherein the validator checks the chain of the trust, verifying all the cryptographic signatures and ensure all the ROAs are validated. And it then compiles all the validated cache that it has with a simple list of prefixes and with their associated AS numbers and their prefix size ranges. Okay. And the next part that comes after this is the router interaction with the uh, with your validator. And this validated cache is actually sent to the router using a very lightweight protocol called as the RPKI-RTR. And the router doesn't perform any cryptographic checks. Basically, it just simply uses this list to actually validate the BGP announcements that it has within the BGP table. And this separation ensures that routers only focuses on the routing part, while the computationally intensive task and the cryptographic workload is handled by the validator only. And you can also opt for redundancy if you want by using multiple validators to ensure some sort of redundancy if you want. But in general use case, people only use single validator in their production network. And now we'll see what are the examples of the validators that we have. The validators, like I said, are tools that check the ROAs and the certificates to build a list of validated prefixes. So example of validator here is the routinator, that is a very popular validator that is built by the NetLabs team, and it's an open source and it's written in Rust, and you can directly run it on a server or in a Docker container if you want, and it's very easy to deploy in couple of minutes. People usually deploy this with the help of the Docker container, and it's very lightweight, uses very minimal memory, so it can run on your existing servers as well. So then you also have one more validator, that's RIPE NCC RPKI validator. Is developed, as it said that it's developed by RIPE NCC, and this is also an open source validator. It also comes with a web interface and an API integration for easier interaction. It's written in Java, like the earlier one was written in Rust, but this uses Java. And the only downside to here for the NCC, RIPE NCC validator is that it consumes more memory when you it is compared to Routinator. It's a great software if you want to have some diversity into your network, but you, depending upon choice, whichever you want to deploy, you can deploy. Both are actually works fine within the network. So DE-CIX also uses RPKI to ensure secure and accurate routing in through the route servers. So these route servers are actually the BGP speakers that receive the prefixes from the DE-CIX customers, and then they are reannounced to these prefixes to other customers. So when RPKI is in place, the router checks if everything is valid within the ROA for the prefix. If a matching ROA exists and it confirms that the prefix is valid, the route server accepts it and reannounces it to the customer. So as you can see over here, the ROA is there for 192.0.2.0 with a source origin AS of 64500. It matches with the validated cache on the your validator, and it sees that it's fine. Then it reannounces that particular prefix to the entire customers that are connected over the DE-CIX LAN segment. Now let's come to the second case. If the route server gets a prefix from a customer but it doesn't match the ROA, okay, in that case what happens? in that case, the route server drops the prefix and does not share it with any other customer. So this helps prevents the incorrect or any unauthorized routes from spreading across the DE-CIX peering segment. One more. Let me show you how RPKS works with the third case. That is the if there is a no ROA for a prefix, so it is marked as unknown. Okay. So unfortunately, most of the prefixes currently fall into this category, and unknown prefixes are generally still re-announced by the route server. And if unknown prefixes were blocked, the global BGP table would become very slow. So unknown prefixes are have to be re-announced to the other customers as well. Let me show you how RPK works using the DE-CIX looking glass. So we'll generally pick up one of the customer where there are many invalids over here. Let's see. We'll just take someone for example. So like here I have CS, I'm seeing that these are the filtered routes for one of the peers. So generally, whenever you see that any prefix is being filtered, you generally go onto the looking glass of DE-CIX and see which all prefixes are being accepted and which are getting filtered. So you generally click on the filtered prefixes, like here, I'm clicking on this. And what we generally do is first and foremost, we check whether the IRR is valid for the customer or not. So you go into the RADB query and see first and foremost if there is a route object available for that particular prefix or not. In this case, who is announced that particular prefix is AS147259. So we have to check whether 147259 is having a route object or not. So if the route object is there, that means the IRRDB filtering check should be passed over here. But okay, so that is okay. Second thing being, if this is an AS number associated with a downstream customer of 133001, then you have to also check whether this particular ASN is added in the AS set member of this particular AS number, that is 133001. So in that case, you can also check with peering DB. For instance, if you want to see what is the what do you say, the AS set associated with that particular AS, and you go into the peering DB and you see here the customer has mentioned the route set as this is the AS set. Let's see if this is a valid route object or not. So yeah, this is a particular AS set by the Airnet Cable and Datacom Limited. So these are the child ASNs that are mapped with their particular AS set. And which was this entry? This was the entry. One of the downstream ASNs being 135718. So we'll do a control F 135718. So 135718 is a downstream ASN that is valid. So even if that prefix is getting filtered, then we have to recursively check whether the 135718 has a child ASN with the mentioning of 14729. So this checks is automatically generally performed on the route servers. We don't have to generally check, but I'm showing you the way why this prefix could be filtered. If this check is also okay, then it might be getting filtered due to the RPKI invalid ROA generation. So in this case, you can go and open one of the validators like we are using the routinator, and you can input this prefix into it and just show a validator. So it's showing that ROA with a source of origin of 147259 is a valid ASN who can announce this prefix. And right now, who is announcing this prefix? 147259. Okay. So 147259 is the correct ASN that is currently announcing that particular prefix. Okay. But currently it's a /23 RPKI hosted prefix, and the customer is currently announcing a /24 subnet. So that also can be a case for the filter announcement. Okay. Because if you are using it as a /23 routes, and you have to announce also like a /23 route unless and until that sequence or the prefix length matches your
But it's showing max length to 24, so it's basically allowed to announce on a /24 prefix length.
yeah, it's allowed, but generally sometimes you have to do that validation check. It's showing that it's allowed for result for /24 as well. It's showing matched, but you have to check whether it's actually getting validated or not according to your route cache also. It's matching here. I can also see that match VRPs are showing here. That's match length 24 is also being accepted. But somehow this prefix is still getting filtered. So there might be some another reason to it that you have to validate why it's actually getting filtered on your own validator server and see what is the exact reason for it to getting filtered. Sometimes what happens is sometimes or the other times the script on the server also doesn't run. So there's an entry point wherein it validates the cache on some specific time interval that you have said that every 6 hours or every 24 hours it should go and fetch for the whois database of the RADB or the AppNic and then look out for this validated cache from the regional internet registries and then it validates and then builds up the database and publishes it. So generally it's been seen that people use a 24 hours interval or a 48 hours interval for validating those prefix and updating the database also. That could also be a case.
I have a question, sir.
Yeah.
When I'm using the /24 IP,
Yeah.
pairing the pairing DB and others, but we are using the /22 and /23 IP using only ILL prefix advertise our telco route. Okay, that time they are working. But when I'm using the /23 or /23 /22 IP, advertise our pairing DB prefix, that time not working. Why? This is the difference between island and pairing.
On which peering you are saying particularly? Specific peering on that it is happening?
Mumbai GPX.
Mumbai GPX, for example, any Google peering or which sort of CDN you are talking?
As like CDN, Amazon, Netflix,
Okay.
everything.
Okay. Generally, it should be getting accepted because see, if the
But
ROI is match, yeah.
But I prefix already advertised, but they are not accepted. Several
In
times
that,
I requesting
yeah,
they have totally mailed to me.
yeah.
It's not possible.
So anything lower than a /24 is not accepted, you are saying?
Not.
Okay. Okay. So that might be a CDN specific requirement. I'm not sure because generally what we see is /22, /23 and a /24 are readily accepted over the CDNs also. The popular CDNs,
Yes.
I don't know whether Amazon has applied this policy lately, but we can see that customers generally announce a higher smaller subnet over the peering session and a larger subnet over their ILL session. So just because that the peering providers or the transit providers can see a shorter subnet over this peering session and route the traffic efficiently. This is what generally a announcement mechanism works. But even if you announce the same sort of prefixes on both sessions, it should ideally work. But if you have seen this issue with Amazon, it's first time that we are actually seeing this because we have also
Okay.
not come across with any of the customers stating that Amazon is not accepting the /22 or /23 prefix when they're announcing. Yeah, because if it's a
Okay,
valid
understood.
ROI, they should generally accept it. That should not be a problem actually to them.
I have a more question. Okay.
Yeah.
That's like I BGP with Kolkata X. That time
Okay.
they have multiple pairs. Okay. So that we have find the pairing DB and find any content from
Hmm.
Kolkata X. That
Hmm.
time BGP configure mean my router, but the BGP not established. And that time, how can I connect with Kolkata X and Mumbai GPX anywhere? They are not responding. Already mailed to him, but waiting for the content several times.
You are
Yes,
trying to connect two different regions.
yes,
Okay, two different exchanges from one single region.
yes.
Okay, but that is possible. Actually, people do it. People connected to Delhi Exchange and Mumbai Exchange also use two different route mechanisms to have redundancy. What problem you are facing? I didn't understood.
Correct.
No problem. You can put your question in the chat. We can have a look and answer it to you later also. That's not an issue.
Okay, okay.
Yeah. So I just wanted to say that why RPKI is important, because many big providers now filter out the RPKI invalid prefixes, which has improved the security a lot over
Let
the past few years.
I chat with you. We'll just find this.
Yeah.
With my router, we have more than these BGPs
Okay.
activate and connected mode. Please check on this.
Okay. No problem. We can have a
This is
look if
my
you have.
core
Yeah.
router. Okay.
Okay. No problem. We can have a look into it separately. Yeah.
Several times mailed to him, but they have not responded properly. Okay.
Okay.
So that the visualization already more than 2 to 3 months
Okay.
downtime.
Okay.
I getting the ping also, no?
Hmm. No problem, Anjan. We can have a look into that separately.
Okay.
Yeah.
Okay.
Yeah.
Thank you,
Sure.
sir.
Sure. So like I said, that many big providers have implemented the RPKI yeah, validation also. Many of the CDNs like Google, Facebook has also implemented. We as an exchange has also implemented this for long time back. And the number of ROAs is also growing steadily. So having your ROAs or your prefixes is a big advantage, because it helps prevent issues like the route hijacking, that you can see that any different ASN can announce your source origin pools if they have a proper route object created. So that also can be eliminated. So if you set up your own validator and you take full control of your RPKI setup, so that will make your network more secure and reliable for future use also. So this session was basically a short introduction to show how useful RPKI can be. So if you are already familiar with it, so this might be just a refresher for you. And for others, I hope this helps you why RPKI and ROS are essential for our secure networking. Okay. So I believe if anybody is not having any questions, we are open to questions.
So I
Yeah.
do have I do have a
Yeah. Yeah.
question.
Yeah.
I
Yeah.
have two AS numbers, and
Okay.
one IP range is particularly bound with one AS, one ROA, one AS ROA. Is
Okay.
that possible that I can assign two AS number with one single prefix?
No, that is not possible, because that completely leads the design standpoint only. You have to define a particular ASN with a one single row. But you try doing it, but I don't think so. They would allow you to announce it simultaneously. You are saying that maintaining the ROAs and keeping it for two different ASNs at, so that you can announce anywhere time you want from different source origins, right?
Yes. Both
Yeah.
ASs are on my name only.
Okay. So generally,
So,
what I can see, yeah, for generally what I can see with IRN is that they allow you to have only one specific AS origin mapped with your ROA and not the secondary one. Generally, this is now a mandatory thing that Google and Facebook and all the other CDNs will also implement, because IRDB filtering is already done mandatory for the CDNs. I don't know when they would be starting up with the RPK assignment also.
we
Once that,
want to migrate the IP address to the another AS number, and we want to surrender the AS number.
yeah, so
But
in that,
that
that case, what you can do is don't create the RPKI ROAs initially. Just have the route objects created simultaneously for the new ASN also. Okay, like your old ASN also a route object, and for your new ASN also a route object. You migrate the entire routing resources on your new ASN on the new router, and once that is in place, then you start issuing the ROAs for your new ASNs with the help of your RIS. So that would actually help you, because if you create the ROAs initially and then you migrate to a different ASNs, then the browsing will stop, because the announcements will not be accepted by your transit providers or the peering partners. So before that only you do the migration, and then you assign your ROAs and create with your regional internet registries. So
even
that
if
is
I
the way
do
to
the
go.
migration first, my browsing will stop already, because currently the IP address is allocated with the old AS1.
Yeah, but you get a permission to have a route object are created with multiple ASNs also. You just have to give a consent from the other ASN uh, actual owner, and then the route objects can be created. You can see that one particular prefix has multiple route objects created for multiple
Route
ASNs so
object is
that,
already route object is already there.
yeah, then that is not a problem for you then.
But, whenever I change my origin AS from old to new,
Yeah.
the Google and Facebook browsing got stopped.
No, but have you added both the ASN in their respective AS set also?
Because of the RPK, ROA, because of the ROA entry.
Because of the ROA entry
Current,
that is happening, you are saying.
yes, my current IP prefixes are in old AS, old ROA, are in old
Old ROA.
ROA entry.
Okay, so you can
Yes.
tell them that completely eliminate that ROA completely and
Okay.
just keep the plain simple route object entry. That is also possible if you're migrating to another
So
AS.
I can request to delete the ROA entry.
Yeah, delete the ROA entry and just keep it simple, only a route object entry, but that's it. No ROA entry has to be done. Because whenever you
Okay.
do a ROA entry, the certificate assignment is being done cryptographically with your ASN number, the prefix length, and the origin ASN. So that is hindering the migration process for you on the new ASN. So this session was a short introduction to how useful RPKI can be. If you're already familiar with it, I have already told you that it's a refresher for you guys. So thank you for attending the DE-CIX Academy session. Stay safe and happy peering. Thank you guys.
Thank you for watching.